Hi, my name is Marcus. I'm going to be demonstrating the Distribution Profile Mixer tool to you. This tool is for domestic customers only. This tool estimates the average hourly load profile for a mixed group of domestic customers from different load classes in the same geographical area. This tool uses load models which have been derived during extensive research by this team during the course of the NRS Load Research Project from 1995 onwards. Typical uses of the software are to estimate the load on a feeder, the total load in an area, or to do what-if scenarios for load planning across a wider area. Published customer load parameters in Eskom's Distribution Master Planning Standard largely use these load models. These same load models are also basis for domestic load parameters published in the National Standard, that's SANS 507 and CSIR's Red Book. Also bear in mind that this software has a user manual. In the user manual, you'll find supplementary information on the application, how to use it, and the background behind it. Please bear in mind, this software is backed up by a huge amount of domestic electrical load research. At the end of this video, you'll find links to this research. Okay, so this is what the application looks like when it starts up. Just bear in mind that this is an HTML5 application, so it may take a little while to start up. What happens is that on startup the application goes and checks the server for any updates, and if there are any updates then it comes back with the latest version of the software and proceeds to run it for you. So the purpose of the software is to allow one to create a mix of different customers and then estimate what the resulting load shape and the parameters of the resulting electrical load will be. The way that the customers are defined is in terms of their estimated consumption. So there is a data entry box here for a histogram of consumptions, and in the box there are brackets for a consumption lower bound of 150 say, and upper bound of 200 units, lower bound of 200 and upper bound of 250 units, and so on and so on. You can scroll down this box and you see it goes up to about 800 units a month, because this is designed for a rather poorer level of customers. Okay, so in this histogram box you can fill in your number of customers according to estimates that you have. Now, where would you get these estimates from? Well, typically you could get them from a tool like DPM, which allows one to estimate consumption for customers if one has their income level. On the bottom panel of the software, you'll see a map display, which you can resize as well. And the purpose of this map display is to indicate where in the country your customers are. The uncertainty on the load profile is related to the weather, and the weather is related to where the customers are in the country. If we look across at the other buttons on the front panel, we've got a save and a load button. The purpose for those is to save and load your histogram of customers that you've entered into the grid here. Okay, now let's look at the other controls on the software. We have tabs here for output, and the first tab is for various forms of load profile output. We're estimating a load profile, and that's where one sees the load profile. And then there is another tab for the time of use setup. Eskom and other municipalities have a time of use settings in their major tariff types, and there's a very comprehensive page here to allow one to set that up, and then there's an about box. I'm going to carry on now and do a load profile estimate for a mix of customers which I define arbitrarily. In the 200 to 250 range I've got 100 customers. I'll pop in another 50 customers lower down in the 200 to 250 range, and then another 50 customers in the 500 to 600 range. So now I've got a total of 200 customers defined, and I select a place in South Africa, click on this map and drag, and I say I want them to be in the Western Cape area, close to the sea, so that's in the cold and wet climate. So now we go off to the profile tab and we're going to get a load profile estimate for those 200 customers. I push the calculate button and here is my resulting load shape. Now there's quite a lot going on in this results page, so bear with me. The first thing is you get your load shape which is shown, and notice that the load shape is shown with a plus and minus bracket of 2 standard deviations. And 95% of the load shape will appear within those 2 standard deviations. Notice that at the peak of each level, we again have indicated values so that you can easily see what values are at any particular hour of the day. This is an hourly load profile from 0 to 23. At the bottom of the panel, there is a results section totalizing consumption and our energy mix, giving us a percentage energy mix for each particular peak standard and off-peak period as it is defined by the metering authority. So we've got the kilowatt hours in the 3 time periods, and we have the energy mix indicated as a percentage for each of those time periods. So 18% of the energy for this group of customers will occur in the peak period. Now if you want to export any of these values to reporting tools, then simply select the grid and you can copy and paste to your reporting tool of your choice. If you wish to save the values from the graph on the right hand side, then just push the save values and it will give you the option to save the reported values as a CSV file, or you can simply save the image that you see on the screen as an image file for your reporting. Okay, now the basic load profile that is shown on the right hand side here is an hourly load profile. If you wish to look at the load profile expressed as hourly load profile per household, then simply change the indication and push calculate, and the graph is then rendered as a load per household. Notice over here that my load profile is expressed in the day type all. Now there are a number of different day types that one can set up here, and there's a choice between all, weekday, Saturday or Sunday day types. So let's select a weekday only and push calculate, and now we've got a refresh on the load profile. Okay, now if we wanted to look at the difference between a weekday and a Saturday for all months of the year, this is what we see for the weekday, and if we pop across to the first day of the weekend and calculate, we see that the shape of the load profile changes, and I would expect the Saturdays to be somewhat lower than the general of the weekday, because the Saturdays tend to be off days. Our Saturdays reported at 140 kilowatts, and if we pop along to the weekday and push calculate, our reported value is 152 kilowatts. And the reason for that is that customers have more opportunities to choose their supper time on a Saturday rather than being forced into a particular regime during the week. Okay, so looking at this drop-down list for season, we see that the season has got choices here. We can express the load shape as the average for all months, high season or low season in terms of the tariff regime of the metering authority, or for individual months of the year being January to December inclusive. Now if we just have a look at the high months and what peak is saying here, recall that we've got a peak at about 152 kilowatts. That's the highest average value. And then we have an indicated peak, and that's a 95th percentile of about 190 kilowatts. So if we cut back now to look at only the high season portion of that, that would be those few months of the year which are regarded as high season. Typically it's the 3 winter months. I push calculate here. Now we've taken a subset basically of the whole year, which has gone into this aggregate load shape. And we see is that the highest value, that's a 95th percentile, is still indicating around about 190 kilowatts. So the ability to predict the peak value is captured in the high season. If we look at the low season portion of that, I recall that that is the rest of the year which is not high season. and push calculate, we find that the peak comes down quite dramatically, and now we're sitting at below 175 kilowatts peak throughout the whole profile. That's the 95th percentile of peak. Now we can inspect individual months, and if I select and say pick a month of March, which is kind of an intermediate month really in terms of climatic severity, and I push calculate, then I end up with a peak value of roughly 150 kilowatts for this community. So what this is showing is that March is pretty much the average of the low season load shapes. Another option is to look at the load as a load duration curve. So I select load duration curve, and this will give me a percentage of load and percentage of time. Now I've got a cumulative load duration curve, and I've got hourly demand on the vertical axis and per unit of time on the horizontal axis. Now per unit of time goes from 0 to 1, and the hourly demand goes from 0 to the demand in kilowatts. That's the total demand in kilowatts. Another option is to look at the load duration curve as a per unit, in other words, a percentage of load and percentage of time. So I select per unit and push calculate, and now my load duration curve is expressed as a percentage of load and percentage of time. Cumulative distribution, you see both of the axes here end on a 1. Similarly, if you wish to export this profile, you can again save the profile as CSV values, or you can export the image clicking on these two buttons. One of the finer points of the load duration curve is that you can also view the load duration curve for a particular peak standard or off-peak time period. And we do that by using this drop-down list. If we want to express only the peak standard or off-peak period, then we select. Now we're just going to view the load duration curve for the peak period alone, and push calculate, and there's your load duration curve expressed only for the peak period. You notice that the load duration curve for the peak period starts at about 200 and it goes down to roughly 61.6. And if we investigate the load duration curve for the off-peak period, we'd expect it to start lower and probably finish lower. Let's recalculate and have a look. Yes, it's come down to 176 and it finishes now at 35.2. So yes, we are drawing a graph of generally the lower parts of the load profile which occur at the off-peak time periods. Because the reporting on the profile page is so detailed, it requires quite a detailed time of use setup. And here we have the defaults for the time of use setup for the reporting page. So the time of use setup is available for weekday, Saturday and Sunday. And on the right hand panel you can select the month of year for the high season, everything else being low season. Because the selection is quite detailed and involves many variables, we've provided a save and a load. So if you want to overload the default with which the software starts up, then save your individual file and load it to run your specific setup. Thanks so much for watching. Have a great day. Goodbye.